We're going to be talking about thermal imaging cameras and how objects radiate electromagnetic radiation. So let's have a look. So here we have an atom that's vibrating, and it is at a temperature of greater than 0 Kelvin. So if it's greater than 0 Kelvin, that means it must have kinetic energy. However, if an atom is not moving, so this is at 0 Kelvin, it does not have kinetic energy, it is not moving. And in this case, it does not radiate any electromagnetic radiation. Okay, so why do atoms radiate when they are at a temperature of greater than 0 Kelvin? Okay, so everywhere there is electromagnetic radiation. There are electric fields, magnetic fields, and when atoms absorb these electromagnetic radiation, the atoms vibrate, and then it will release these electromagnetic radiation. Now, these radiation can be long waves, or they can be shorter waves, as in the wavelength could be really short. So if you increase the temperature, then the frequency of the wavelength will be higher and the wavelength will be shorter. So the shorter the wavelength means that it has more energy. That means the frequency is high. Okay, so now we go into thermal imaging. First, what are the components, or what's the flow diagram for a thermal imaging camera? First, you need a lens to focus and to allow the infrared radiation to go into the camera. So the infrared goes through the lens, and then it goes through an array of sensors, and these sensors have pixels. Now, there are two methods of thermal imaging camera. So one does not use quantum mechanics. Another one does use quantum mechanics. All right, so the pixels, what it does is that when the infrared light hits the pixels, it will convert the result of that collision between the sensor and the infrared into an electrical signal. It goes through a processor, so this could be a computer or your mobile phone, and then it generates an algorithm, and that generates a picture that could either be colored or black or white. Now, so the one that doesn't use quantum mechanics is the one that doesn't measure photons, and in this case, the infrared light that affects the material that it hits, and then the resistance of that material will change, or the voltage will change, but we're just going to talk about the resistance in this case. So here we have an infrared light, and it hits a material, and the material, its resistance will change because of the energy change. Basically the infrared light hits the atoms in the material. And it's called a Bolo Meter. And because these needs to be very tiny to fit inside the camera, they're called micro bolometers. Now, what it does is that it measures the power of the incident electromagnetic radiation. So, for example, if the temperature is high, then the infrared will give out at a higher intensity. So the higher the temperature, the bigger the intensity of infrared lights that is emitting from the object. Now, as it gets higher and higher, because it becomes more energetic, the visible spectrum might be visible. And as you keep heating it up, then it goes through red, it goes through yellow, orange, then yellow, then white. Now, what is a CCD camera? It is a charge coupled device. Right, so this method uses quantum mechanics. The previous one does not use quantum mechanics because the previous one uses the change in resistance. This one is when the electrons are knocked off when you have an incident electromagnetic wave. So here on the surface, you've got atoms, and then the incoming light hits the surface, and then the electrons are given out because the electrons have been given energy from the incoming light wave. So the electrons are given off from the incoming infrared, for example. However, if you have a more energetic incoming electromagnetic wave, the electrons are more likely to be given off because it is more energetic. However, in this case, we've got infrared, and when the electrons are given off, you have negative charges that build up and then positive charges at the bottom. And of course, this is called the photoelectric effect because the photons are coming in and the electrons are given off. Now, the reason why it's called a charge coupled device is because the charges are separated. So that is a CCD camera. The charges are separated from the electrons and the positive atoms remain at the bottom. Okay, so let's just say that the body, your body is suffering from an injury. Then you got the blood cells that accumulate in that area, and then you got white blood cells, and so therefore it gets hot. Now, hotter objects will emit more intensive infrared radiation. So the more hot it is, the infrared will be more intense. So for example, if you have an injury or infection, that will be able to be detected. And infrared can also be used to measure the flow of the blood in blood vessels. By measuring how the infrared gets reflected or transmitted, you are able to work out the blood flow of the inside the blood vessels. So here you have the infrared hitting the red blood cell as it's moving, and the infrared gets reflected back. Alright, so now we're going to be talking about X-rays and how X-rays can get affected by different densities of materials. So I'm going to draw two different types of materials on the board. So here you have an incoming X-ray, and the X-ray that comes out is attenuated. Now, attenuated just means that the energy is lost. So the energy is lost as the X-ray goes through the material. So the top one, the attenuation is quite low because some of it gets through. However, the more dense material at the bottom, as the X-ray goes through it, the attenuation is much more, meaning that energy has been lost a lot more. So for example, bone, because bone is more dense than tissue, the X-ray gets absorbed into the bone. Now, what other functions are there for X-rays? Okay, let's just talk about a gamma camera first. Now, a gamma ray, so first you would have a gamma isotope or tracer. Now, a tracer is where you have a chemical that will release gamma rays because it is radioactive. And then let's just say you put it into a pipe. Now, because there's a leak, then the gamma rays can be detected because obviously gamma rays can go through. So you would measure a lot of gamma rays if there is a leak at that point. And the X-ray is a 2D image. What is a CT scan? Now, a CT scan is where the patient goes through a machine and the detectors, or the X-ray source goes around the body 360 degrees. And so the detectors on the other side of the X-ray source will detect the X-rays coming out, and as it goes around the body, it will form a slice of that X-ray image, and you can make a 3D image of it from the 2D image.